Works even better if I unmute the mic. But we'll see if that works. Okay. Well, Twitch is working. Let's see if YouTube is doing anything right now. There's this. That looks like the stream. I got it muted right now. Let's. Okay. It looks like we're live on YouTube as well. All right, and one more little thing to check. I'm gonna mute that one, otherwise it's gonna get very confusing for me. Now, why is this chat just forever loading? It's the restream chat. Okay. Okay, let's see. Good. I do have this here. That's nice. I just don't want to be eating all my bandwidth having this stream running. So let me see what I can do here. Okay, well, this looks like we've got a chat. This is just a test chat message. It's boring. Test chat message. Hello? It's me. Beard with a man on it. Okay, it works there. Yeah, that seems to work. So I think I'll just put this chat somewhere over here. Not too far from the camera. And let's get going with this. Oh, not many bots on the Twitch chat channel today. They must be busy or tired. Alrighty. So, first things first, I'll make this a bit bigger. Oh, hang on, there's second things here. First things first, I'm going to stop these two streams from being from streaming into onto my system, because that is just going to slow everything down a lot. Yeah, hopefully that leaves a bit of bandwidth for other things. Like actually sending the frames of the stream. Let's try a bit more light as well. Why not? I'm a bit further to the left today, you might have noticed. Although that may appear to be a little bit further to the right, I'm a bit further this way. So, yeah. Left and right are reversed until I get around to moving this over there. Then I can stop flipping it. Alright, I will get around to introducing what's going on, which is game development. Let me run the game. You can't see that in the background right now. But I've been working on a little game called Family Tree, trying to get all the systems finished. I thought I was going to release the end of last month, but I completely underestimated how much stuff was left. So that's part of why I'm making a bunch of small games this year instead of setting out to make a big one. The main reason is I have way too many ideas, and it's really hard to settle on just one. So making small things is a compromise that lets me make more than one in a finite amount of time. So I was working before. Here we go. Now, I don't have the menus open. It's a little loud, but I'll turn that down here. I think it's fine over there. There we go. So right now we're generating trees, and actually let's go in the game manager here and just say 3 generations, because then I can actually demonstrate the game. Whoa! 2, 4, 6, 8. I think I've got something going wrong there. Interesting. I don't know if it'll affect anything. Let me demonstrate the game first and see if it works. Okay, so who would be this person's parents? Well, this hair is the same. That's the same hair, but a bit shorter, so that's a reasonable candidate. Yep. And someone with longer hair, and that skin color seems in between. The music just stopped. Have we had a thing? Missing reference. No line renderer. I'd say that's related to the fact that I've got too many of these on here. Let's see if we're paused, so let's just unpause. Let's see if we generate level with 4. So that's a bug. Let me just pop that into... I better deal with that today since that seems to be completely breaking it. Bug. Generations still makes 8 great-grandparents. Oh, just grandparents. I'm still just there. There's definitely a bug. What is that notification? Who would notify me this time of the morning? I don't know. I have a Galaxy, and for some reason, the geniuses over at Samsung have decided that we would never possibly want to order notifications by the time they came in. And so if you get a notification, you have to note what time it is and then scroll through your notifications until you find one that has the right timestamp. It's just ridiculous. Do they have their reasons? Or is the reason just that they are not doing very well at their job? I don't know. I feel like I need to adjust this audio a bit because I feel like I'm getting into the red a bit. I might just turn that down slightly. I know there are some more advanced settings I can mess with, but I'm not an audio technician yet. I'll get there. Right, and what I'm going to do is actually remember to switch over to here before I start showing the game, because, yeah, I don't know if I should even ever use this view, because I just forget that I'm on it, and then start showing things over here that you can't see. Or I just need a big extra monitor right here at the bottom that shows exactly what's visible. So this is the game. It's called Family Tree at the moment, but I might think of a better name. We need to figure out where all of these fit because the glue or whatever was holding these photos in has degraded over time. And so we just don't know who this person's parents are. It could be these two. Yeah. Skin color seems close enough. This one's hair's longer and wavy, and this one's short and curly, but that should be close enough. No. Okay, they're each valid parents. I think that's... Oh, this hair's just too long. We've got someone with shorter hair. There. And you're probably a parent of that one. But where does all this green come in? We've got all this curly hair. That's... Oh, there we go. We've broken something again. So we're getting this error, which is even without the 3 generations. Could be related, but I'll just mark it as a separate one for now. There we go. It looks like this is going to be maybe a bug fixing stream rather than a camera painting stream. Although I can continue with the camera without fixing those, but I better do those soon. So yeah, very interesting. Well, I might leave that there, and will I? No, it's easy to reproduce. This has happened the last couple of times. Well, that's good. Probably stopped me from spending too much of the stream just playing the game. It's a risk when doing game development, just stopping and playing the game instead of getting things done. So yeah, basically, when you get all these people in their positions, you get the level complete dialogue, which I need to change. I want it to sort of zoom out to show the tree and give you a way to advance to the next level or go back to the menu without covering up that tree, because I, for one, want to see the tree that I've just completed when I complete it. That'll be more relevant in version 2, which will have a story element to it, but I don't know when I'll make that. I'm purposely thinking about a version 2 just to make sure I don't overdo the story element. Oh, that is scaled. Oh, I see. Yeah. So scrolling normally zooms while the game is running, but since it's paused, it doesn't. So I wonder what the deal is there. That's... Oh yeah, so that's trying to update the line renderer when I remove that from there and when I add it, because those are both cases where it'll update that. So if I pull this one out of here, you can see it updates. That's interesting. Anyway, this panning when you get to the edge of the screen, I did that last stream, but it's a little bit clunky. Oh, it's also capable of panning way outside the bounds, which is not supposed to happen. You can see it just snapped back within the bounds as soon as I clicked on here, which did a little, triggered the dragging code, which does clamp it, and zooming out also will clamp it. But yeah, apparently panning does not. Okay, so that's a bug to fix in there. And that's probably something to do a bit sooner. That should be pretty fast to fix. Alrighty, so yeah, I guess what I'm getting up to today, just jump back to there for a second, is getting that clamped within the bounds. I want to do something where it'll start panning when you get somewhere near the edge. That music's distracting me. Let's just turn that off. Background music. Volume. There. Oh, maybe just a bit quiet. I've got it turned down for the stream, so it shouldn't be making it hard to hear me. But I also need to hear myself talk, otherwise, how will I know that I'm talking? Yeah, so basically I want this, when I get to maybe here, to start very slowly panning across, and then if it gets right to the edge, then I want it to pan quickly, which will be relevant when you're zoomed in, so you can, there you go, see that feels really slow. So actually can get to somewhere. Is that going to crash it? Let's test. It does crash it. So that's interesting. Could be related to just it being the final generation. Yeah, I think that's just happening with the final generation. All right. Bit of info for that bug there. But let me just put this here. And that is what I'm working on. Yeah, I need to curate this backlog a bit, but I won't do that right here. I don't know how interesting that is. I think actually making the game might be a bit more interesting. What am I doing here? I think I want to just make that a bit smaller. And let's get this code nice and big to work on that. All right, so the way that the here we go. The way that the drag is working. No, let me start again. The way that panning, when you are dragging a picture near the edge, works is there are these bounds, and if I go like that, we'll get a better shape. And I will just run that again. So whenever at the start and when the camera resizes, these get moved and resized to sit on the edges. And then this, when this collides with it, that triggers the dragging. And I decided to do it that way. I could also just in code figure out when something's getting near the edge. But this allows me to control these a bit more. So what I don't have is clamp within bounds. So this is the trigger over for those colliders on the camera. So this is a camera drag script that does all of the dragging the page around, and also when one of those photos, which are just using an iDraggable interface, so that way I can implement that interface with anything. Whenever they collide with any of those edges, I know they're near the edge. And so what's happening here, we're just setting that target position. We make sure we don't move it in and out of the page. We just want to move it across. And then we interpolate. Now this is probably what we want to use here. So I might just put that there. Is there a refactor for that? Let me just see. Yes. Introduce a local constant. Yeah. That's the one. Probably want that one, which will do the same thing since I've only got it once. the more I get used to using these, the better. I don't know why it only has const, but that's fine. I can delete that. And this is the speed. And I'll make that not a const because I do intend to change that. Well, no, I won't really change it. It'll be per frame. I'm not going to change it. But I'll figure that out based on how far we are from the edge. I might do it a different way too, because I might want it to pan. Right now it's based on the center position and it's panning in whatever direction it is to where the thing is. So that if you're 2/3 of the way up here, it will pan slightly upwards, which might not be desirable behavior. I think we only want to pan diagonally if it's getting near that corner there. So, yeah, but we don't want this. So we want to clamp within bounds. Camera position, yeah, that's what I want. Clamp, not calm. Clamp within bounds. That should fix that issue where I was able to pan way off. I'll just run that to make sure, and meanwhile I'll think about the next thing, which is using the distance from the edge to get the speed. We're going to run. There we go. Okay, so grab that and just, yep, that's not going past the edges anymore. That feels so slow. Yep, there we go, good. We clamped within bounds. Done. Oh, let me make sure that, oh geez. I've done it again, I've gone and left it on the chatting scene. Maybe I should just delete that chatting scene. Or I just need a big thing straight over the middle of my display here that says you are in chatting view. I'm sure there's a way to do that. Earlier I pointed to these bounds, and when I run this, they get snapped onto the edge of that. And anytime the camera resizes. What is that? Interesting. Some kind of mouse software is generating weird things. I'm just going to put this over the top of that so it doesn't keep bugging me. Okay. Now we'll pick up all of the stuff that was not visible before as we go, because this is all I've really changed here. Is just wrapping this clamp within bounds around this new position. Clamp within bounds just makes sure that the camera is not showing anything outside of these bounds. These are the bounds here, camera bounds. I've just got a couple of game objects there that I use for the corners, and those are dropped into this camera drag script here to connect them up, and then I use those for to get those positions that I want to clamp between. Anyway, I want to press on, get some stuff done today. So yeah, we want to use the distance from the edge. So I don't know if you saw or not, but let's get that running while I take a look at this. So right now it's just a constant speed. If you're zoomed in, that's really slow, and if you're zoomed out, it's fast-ish, but it's definitely not ideal. So grab that. Let's see, that's that fast exactly. And if you zoom in, is the same pixel speed relative to the camera, but it's really slow. And what I really want is for that to that's not bad. To make these colliders a bit bigger and to have the movement start as soon as this gets somewhere near the edge and speed up as you get closer to the edge. And also not go diagonal too much, so that'll go diagonal here. Really only when it's down in this corner do I want it to go diagonal, so I'll figure that out as well. So that's where we are. And so I need to basically calculate this speed based on, I think I want to get the distance from both edges. So let's just write a few comments here. That'll be like minimum of distance to each edge. So I could rearrange things so that the colliders each have their own script and notify the camera which collider was collided with, and do it that way. But this should make it easier to, like, it's more flexible because I can get the drag going a bit diagonal as I get near the edge, and that kind of thing. And I need to calculate distances anyway. So I want to get the minimum distance to each edge for that, and then if over threshold, speed is inverse distance inverse distance, do these things separately, scaled over max, min might be 0. Based on pretty much width of the collider. Something like that. So there are a few adjustments I need to make, but first of all, let's just get that distance from the edges. So let's start with the top. Now, so these, I think, are indicating where the edges of the screen are. Okay, so we've got this camera size here. And that's giving me a handy vector 2 instead of this orthographic size, which is the half of the Y size. And then this computes the X size based on the aspect ratio. Does it? Don't know why I'm not using camera to aspect. This is the aspect here. So there you go. Everybody needed to see me delete a bunch of spaces there. I'm just going to duplicate this and comment it out. And use this this is width over height. So so it's been divided by height, multiply it by the height, gives us the width. Yeah. So that should do the same thing. I'll make sure that works. That is used here. So next time I'm making sure it's within bounds, I'll make sure that actually works. Okay, so now to get that top distance, we basically need to get the, well, we've got this position of the target already. I'll just move that up there so that it's accessible to us. And it's going to be, I'll just draw this, by the way, because it's much easier if I can just remember how to open a program. If the computer can remember how to open it, come on computer, you can do it. There we are. Okay, let's open these. Just here. So here are some sketches from before, which make little to no sense without the context of talking about them. But this was from previous stream, and this is all about. Where are my layers here? Oh, I have the background selected. So good, I haven't been drawing on the background. This is the pan camera on drag sketches, so I'll stick with that. And so what we're dealing with here is we're going to have, I'll do a new one here. We've hit one of those colliders at the edge of the screen, like so. So we've got a picture, and it has, oh, this is interesting. Let's say it's collided here, and that's the actual position of it. And so now it has a collision really with both of these, but it doesn't matter. Just whatever will trigger it. And so what we're going to be dealing with here is we've got a distance there from that edge. So really, let's just say it's that vector. I won't do arrows on both sides. And we've got a distance from the top, but we've also got a distance from the bottom, because at this point we don't really know in the code which edge is closer. So basically we've got these vectors that we need to compute. And so that's going to be a way to think about vectors if you haven't done much of that is, let's say that we're centered on the screen and that's 0, 0, for example. That's the origin. Then we've got, this is a vector to this position, and you can pick that up and put it anywhere. It's still the same vector, because the vector just represents how, like a direction and a magnitude. So that is that vector, and if we want to get the vector to the edge of the screen from here, then the edge of the screen is at that vector, and like the top of the screen, where it lines up with that is this vector here, and like that point there. So basically a coordinate can represent a vector from the origin to that coordinate. But you can then pick that up and use it to compute other vectors, because if we want to get a vector from here to here, then we can basically take, let's use, say, orange. then we basically want to take this vector here, move it. So what we're looking for is this here. But from the origin, that would look like this. And the way that you get that is that you take this vector here, which is the starting point of the vector, and let's change color again. And you move it, you reverse it, and point backwards. So if you get the negative of the vector, that'll point the other way. And so then you have that corner minus that starting position. And so we've got, well, this won't give us the top distance. This will give us a vector which has two components. It will have both the distance from the top and the distance from the side. Which would be represented on that vector as these distances along these edges. So we basically need that position in the corner, top right corner, doesn't exist yet, don't worry about that, minus our target position, yes. Oh, should have hit tab for that. So where's the top right corner? That is going to be based on our camera position. And we're going to need to add on that camera size. And that's a vector 3, that's a vector 2. Is that what you're complaining about? Yes, it is. Vector 2 pause equals transform the position. Now we'll use that. So the third number in that vector is the distance away from the camera. And we don't really care about that here, so let's just deal with vector 2, and that allows us to add on that camera size. I'm going to use that again, so let's not calculate it twice. Oops. Yep, cam size. All right, so that should be the top right corner because that size is not that's like the half size of the camera, because this orthographic size is half size, I believe. We'll very soon figure out if it's not. Or I guess if this is wrong, it will just make it move twice as fast because, half as fast. The distance will be half. Okay, so the top distance, what I've got here, top right corner, and maybe we should be dealing with vector 3s here. There's another vector 3. Let's just make that a vector 2. So these positions are all world space positions. And I think that orthographic size is in world units. I should make myself a little printout that has which space each of the units are in. Screen space, world space. And well, there are two screen spaces. There's the pixel dimensions space, and then there's like a 0 to 1 UI canvas space, I think. Something along those lines. Okay, so that should give us our distance, both the x and the y. And so that gives us, that's gone all messy. Let's use over here. Let's use this one. So that gives us the x and the y, gives us a vector to that corner. So the x is that distance and the y is that distance. So that's good. We can do the same for the bottom left corner. We just need to use the negative of that camera size vector to get that. So this is really top right distances, yeah, distance up left. Okay, so we've got that vector and this vector to pretend that hit that corner. From that, we can get the distance to each side. These are all floats here, by the way, which I can probably have it automatically. Oh, there we go, they're not all floats. That is also the wrong key shortcut here. So let's just have it use explicit types instead of var. There we go. Using explicit types has caught me in my lie. Those are all vectors, vector 2s, because they're pairs of floats. This should be a float, which is, so let's do horizontal. I might actually want to change some of that. So this will be giving me a vector pointing that way, but I'm interested in the magnitude, so I want positives. So I actually want the negative of this vector, or reverse the direction of that arrow. And so instead of pointing from this object to that object, I'll just go the other way. There. So that's basically taking what have we got? Bottom left corner is this vector here. Now let's get a different color so it makes sense. Bottom left corner is that. We've taken our position of the camera, which is the pink dot here, and subtracted cam size, which is that vector there. So we just flipped that vector to that way. And that gives us that. So by subtracting that, we're just flipping that to this way. And by starting at the target position, we're basically going that way, and that'll just tell us how far away we are. So we're starting with, that vector there. And we're adding that on there, so that gives us this distance away, which should be, if we were to take that and position it here and flip it, that should be the same as this red vector there. Anyway, we don't need to think all of those things. I feel like first of all, I feel like I'm drinking a hair. I don't know how a hair could get to my mouth. Very strange. Now, let's get this done. I feel like I've talked about it enough and I'm going slow. So I'm on to the minimum of the distance to each edge. So the top and bottom distances just come straight from there. So just realized I will need to know like which edge it is. So this isn't an offset. That means that's a sorry, not a distance. It's an offset. And so now for the distances. What I was going to do was do like a math.min between the two horizontals, which is the x out of those. But that's always going to give me the bottom left one because that's going to be negative and the other one will be positive. So then I was going to get the absolute of this to make it positive. And the problem here is that then I'll get the distance, but I won't get which of these was the greater. Like which side it's closest to. So I really do need a negative or a positive. But let's just deal with a positive and go from there, I guess. So that's the positive distance. And we could do the same for vertical. And that's just going to be the y coordinate out of each of those. So that gives us the scale of it. And we want some kind of threshold. I'll give that a bit of name when I move it to a different context. And that's, now this is how many world units. Is it how many world units? Let's just go with 3 world units. Actually, no, a person. I'll just grab my prefabs here. That person prefab. Are these world units here? Photo outer. It's got a scale. I'm looking for the size in world units, or maybe I'll grab the collider here. That looks like it's 8 units wide or something. Unless these are world units. From memory, it's about 4 units to the edge. So let's just say we wanted it at about 6 or something. It's interesting. Is that doing that? Oh yeah, true. I need to get that back to vector 3. That's fine. Alright, so I've got a threshold here. Yeah, that looks good. That's a good suggestion. To move it horizontally. Vertically, okay, and how am I going to decide? So we're going to need 2 speeds really, because it's how fast are we going up and how fast are we going across. But I guess we can get that using our target position here. That'll give us like the ratio of how much up and how much across we're going. So what have I got right now? I've got that thing called target pos. Let's go with another vector 2. Vector 2, let's go vector 3. This will be our actual target position. Yeah, let's rename this because it's not our target position anymore. That is the position of other. So our target was equals. Let's start with the current position of the camera. That will be good. And because that'll have the right Z position. And then if we're doing a horizontal move, now we got to figure out which side is closer out of the left and right. So it's just these 2 numbers here. I don't want an if there. Probably. Our x offset is equal to. All right. So basically, just do a ternary here. So if the top right offset is greater than the absolute of the bottom left offset, then that means we are going in the positive direction. Okay, question mark. Otherwise, we'll just go with bottom left offset without the absolute because we don't we do want to keep the negative of it. That's good. Can we do that? So we're going to update that. I hope so. And let's just do the same thing here. Let's grab those. That. I think I've got this the wrong way around as well. So what we actually want is whichever one it's closer to. So if this is less than that, it means it's closer. There we go. That would have just moved in the opposite direction. Okay, so we've got that upset there. What are you doing? Yep, same as the other one. Okay, so now we've got that target position. We're interpolating to that target position. So now actually our speed probably needs to be greater. Don't need that. Closer it is to the edge, so we need speed to be the inverse distance as well. So I won't do that right now. Get a relevant edge offset and use that instead. So basically this is just a vector of the offsets that are relevant, that we care about. And so we can use that to figure out the speeds. Given the offset. So yeah, this is sort of like it goes faster the further from the edge you are, which doesn't make sense. And our threshold is 6. So we'll use that threshold. So basically, I think we just want 1 minus. Or -1 minus the thing. When I say 1 minus, I mean 6 minus. So this actually we want to deal with the threshold first. So yeah, I think we need to get I think we are going to be doing a start bin of this. Oh, I've got that. Got vertical distance already. So yeah, let's duplicate that for a second. And just get an X direction. That's going to be 1 or -1. So whichever is the lesser of these distances, it's going to be 1 or -1. Same thing down there. Okay, so that's our multiplier that we can use to get it to the correct direction. But first, okay, we've got our horizontal distance here. So yeah, we don't actually need that, I think. But what we do want... Now we want to scale this to the right size. So that's going to be threshold. So it's less than threshold, good, that makes sense. Minus the horizontal distance, yes. Yes, there's going to be between 6 and nothing, depending how far it is. The further it is, the slower it is. That seems fine. And just multiply that by the X direction. Okay, there we go, same thing here. Yeah, so we'll just change that to be Y direction. And it's just going to be again 1 or -1. And threshold minus vertical distance. Yes, please. There we go. And multiply that by the Y direction. Okay, that should give us a relevant edge offset that has been calculated. Not even just the relevant edge offset, actually, because we've now got this scaling in here. So that's good. Let's rename that to pan direction and speed. There's that direction and speed for our pan. And this speed here is just an adjustment, really. Might be good to scale that with frame rate. Have we got look at time.delta time? Yeah. Yeah, let's use that. Okay, so I'll probably need to scale this at a multiplier of some sort. Why don't I just do that here, actually? Scroll zoom speed. It looks like it belongs right here as what do I call it? I was going to call it drag pan speed, but that's ambiguous because you can hold and drag the book as well. So drag to edge pan speed. There. So I'll use this to just have that pan go faster or slower. Where are my changes? Just here. And what I could do is scale that whole thing. That'll do. What do I actually call that third? Just A, B, and T. Okay. Speed isn't quite the right name for that. So I could multiply this. Sorry, I could multiply that by that, and it would have the same effect as this, but technically be more correct. Don't know, let's run it and see what happens. Okay, let me zoom in first of all. Just check that this works at all. Okay, nothing that way. Nothing that way. Where are those camera bounds? They're there, it should be hitting them. Just clear all that other logging. So we're getting nothing here. So that's not a great sign. Wait a minute. Where did I set that pan speed to? 1. I think if you get past the edge, did that make it go the other way? I need to check on that, but right now we got nothing happening. That's not very encouraging. Let's just check here with little debug log that someone is here. Someone is at the edge. Sometimes I try and make things funny, but making them clear would be better. Yeah, that's fine. I'm not going to keep that for long. There we go. Someone is at the edge. It takes them one step closer to the edge, and we're about to pan. Because if we're not even triggering this code, that would be one thing. More likely I've just got a mistake somewhere here. Okay, so yes, it does know that someone is at the edge. So I think I wanted to spit out some values here. I also need to make those colliders a bit wider, but okay, so I'll actually just put this a bit lower and see what we're ending up with here. So I think I want really something right down here. Because then I've got access to all of those variables. And I won't worry too much about labeling things. I can figure out what's where. What kind of things do we want? Yeah, let's go to the top right corner, bottom left corner. distances. Horizontal and vertical. The thing we really care about probably is our new position. Yeah, pos and new pos. That was the main thing that's happening, and if they're the same number, then or the same vector, that's not going to be good. Look at our corners, our distances, our pan direction and speed. Grab that in here. Interesting. Anything else? Maybe that time there. If that's too small. And that's the thing, it may be panning by a tiny, tiny amount. And I'll look at that as well. Just look at the actual position here, see if that's creeping along. Where was that happening? 2, 3, 4. That could be relevant, but maybe not. Okay. Let's grab some people here. Let's clear that so I can see. And start with them not touching the edge and then touch the edge. All right, what did we get? Lots of output. Apparently we are scaling. What we want to do is this. So the one on the left. Okay, so we've got position. Which is apparently a vector 2. Okay, yeah. New pos. This is vector 3. That's okay. But we got 2 at 0.04, 39.36, so that is the same. So that's one problem. I won't bother writing all that. Let me try and use my working memory. Test whether it works. All right. So if we've got our transformed opposition, sorry, yeah, new pos is the same as pos. There. Next number we've got here is pan direction and speed. And it looks like we want negative 0.15 on the x direction and 0 on the y direction. That looks correct. So that is correct. I'm not using it anywhere. So we should be going, yeah, okay. Debugging successful. This is supposed to be using that to get that offset. So let's just regenerate that. The joys of live coding. We get to show all of the little silly mistakes. And that's actually sort of part of the point. There's a big problem with imposter syndrome. It's very easy to see the final results of someone's work and feel like it's sort of beyond what you're capable of because all you see is their final result, not the mistakes along the way, all of the little trips and the things where instead of going to the left, it goes down. That's fun. And instead of going up, we go, no, that's fine, that's going up. It's going left, it's going right. We're going the correct direction. We could do it a little bit faster. What? That's another thing. Our camera has been moved. We want it way back here. No, we want it at -10, I think. -10 or -20? So, a few issues there. -50, 40. Apparently -40. So, yeah, got a few things going on there that are wrong. I need to make those wider as well, but yeah, our camera's getting closer and closer, so everything's disappearing. So that's interesting. Yeah, if I get it past the edge, but it's still colliding, it pans the other way. Cool. So a lot of weird behavior here. Anyway, what I was halfway through saying is that a big problem we have in the world is a lot of potential creators see what other creators have created. They see their newest work that they've made and they see the output and they don't see any of the struggle, any of the mistakes. They don't see when they stumble. And so it's very easy to think, I'm not as good at this. I don't have the capacity to do this. I'm not as put together as that person. And I don't want to contribute to that. So I don't want to write this code ahead of time and then make a video that just shows me writing that code from a script with none of the mistakes. And then give a bunch more people who might make wonderful games, give them this idea that they can't do that because there are no mistakes made and they make mistakes. Making mistakes is how we learn. And programming, a large part of programming, a huge part of programming is just figuring out why things are broken and making them not be broken. And most of the time things are broken because you just made them wrong in the first place. Like these bugs here, they don't come from somewhere else. These are bugs that happen because I've done something wrong. And I figured it out by seeing something breaking. So that's one of the goals of this channel here is to show the whole process. Don't just show the happy path. Don't just show when it's all sunshine and rainbows. Oh, that reminds me, there was an amazing rainbow yesterday. Best one I've ever seen. Full arch with a second full arch. I do have a picture somewhere. But right now I'm trying to fix this, so this is like riddled with problems. We're starting with transponder position as our target position, and then we're doing nothing with it. So I've got our direction and speed. Yeah, okay, this will fix some of the stuff. we're targeting not. I'll just put this down here. We're starting with the current position, and then we just want to add that pan direction and speed. And is that ambiguous? Vector 3 and vector 2. Really? You can't just add? Well, in adding a vector 3 to a vector 2, I guess it could give either, but anyway, if I just treat this as a vector 3, we should be okay. So that third element of it is just oh. No, actually, okay, well, the fact that I was using a vector 2 here that had 0, and then that's going to my target position, that's going to be interpreted as a vector 3 with the third, like with the Z as 0. So that's why the camera's moving towards 0 from where it is. And I think actually just having this as a vector 3 to begin with will be useful, because then we don't need to cast it here. And it's just going to have a 0 in here. And now we've got our actual proper target position that is that. And so that's where we're targeting. So that should fix a big part of that. Another thing is the going beyond the edge. Which I think I can fix. Okay, so that's... Oh no, going beyond the edge does just go faster. It's just when you get out to there. Okay, so camera position here, -30 was the sweet spot. Seems to be working. Let me zoom in. And it's a bit slow, so let's get that up. Let's try 5. Yeah, you can do it slow, you can do it faster, and I have a feeling if I just make those colliders a bit wider, it will help. Now if I zoom out, hang on, those colliders, they're staying the same size, right? So the collider's bigger here than here. So I'll actually, I might scale those colliders with the speed. That's looking pretty good. So we'll keep that speed of 5 outside of play mode. And okay, so when I move those colliders, screen resized, set camera size. So yeah, I made this set camera size to replace all my calls to just setting the orthographic size in the last stream, so that I could position those colliders. And it does actually get the sizes, but it's hard-coded to being 3 wide or tall. And then using the camera size to vertically or horizontally get them to the right size of the edge. So instead, I should scale that. Now, how am I going to do that? Okay, so my orthographic size, I think I've got a max here, clamp camera size. The maximum size is just determined by the bounds. the minimum size. I've got this min or the graphic size variable here, which that limits how far in you can zoom. And that's going to be the height or width. And that is set to 13. So basically, we're not going to be able to get bigger than about 13. So if we wanted those to be, what do we think, like not 25%, maybe 20% of the width. Of the camera, would that be reasonable? Let me think about that for a second. Let's say for 20% of screen width, instead of 20% either side and 60% in the middle. 15% might be better, but we can play with that number. So if we wanted 15% of screen width, then they're actually going to need to be like 30% of width, because the half is hanging out. And I'm fine with that, because it does mean that if you drag something outside the screen, it's still going to be in contact with that over more of a distance, so that's fine. But cam size is half screen, so double it. Double it again, so we're going to end up with then 60% of the width. And we do want both of them to be the same, those distances. And so I think we just base it on whichever is less. Like this. That kind of thing. So that's based on camera aspect. Okay. So this is going to be our collider width. And let's make just a monstrosity of a line of code here. So do I want to use the min size at all? No, but script that. Okay, if it's less than 1, then camera's orthographic size. Okay, so I'm going to get, hopefully that'll be the right size here. Let's call that proportional size, the proportion of the screen width. That'll be, so I'll say 15%. That gives us our desired size of them from the edge of the screen. So we'll double that. And that's times 2 because we're dealing with half sizes there. Oops. That's our base half size. Double that. And we're going to get our proportional size here, which should be a float. And let's make sure these are floats so we don't accidentally get into integer multiplication. So that's the proportional size we want of that, and then double it so that half of it can stick outside the screen. And maybe that's what we want for our collider width. Look at the time. I'll wrap up after this. So looks like those bug fixes will be next time. I could hear someone out there, so. And I'm not surprised. It is about time for people to start waking up. Let's just see. Oh, whoa. Now that was moving when I was moving this. Oh, interesting. Okay. I'm not using the size of those colliders at all, really. So if these people are inside these colliders, that breaks it when I grab them. So I'm holding this person, but it's also dragging the screen. I think that's also a bug. Probably related to these people were blocking clicking on the colliders. Nice, another bug. So this one, I'll do the old caterpillar, is drag a person through camera collider. Causes both person drag and background drag. So I think what's happening there is that when you click to drag a person, it has oh yeah, should zoom that. Yeah, so these are keeping their proportion anyway, and that's correct. And I really probably should be using where's that threshold that I had set in here? There, that threshold. What I really want is to use something here. Let's just duplicate that actually. And it's not going to be drag to edge pan speed. It is going to be What is it? There we go, something like that. And 0.15 didn't seem quite right. Because these are like huge. They look like they're taking up about a third of the screen, so maybe I've doubled something too many times. Let's start it at 0.5. And that's what we'll use down here for proportional size. So we're grabbing, oh, actually I can just check if I go like that, do they get smaller? It's supposed to be using the lower, like the smallest one, but they're actually getting bigger when I do that. Yeah, so this is backwards. Just flip that sign there, that should get us going the other way. So really it's the one at the top and bottom here that, yeah, that's the proportion that it's using. Okay, so that was going to get me that, and then I need to use the same thing for that speed, this threshold. And that's going to need to be the proportion of the camera size. Just wondering if there's any reason not to just use the same, like use the computed value from like here. That's the proportion. That's the collider width. So I'm computing this more than is necessary, but it should be fine. Okay, I don't need any of that stuff there. Okay, so now we're using that there, and you can do the same thing for up here. Just there. We'll just divide that by 2. And why do you insist on? What's the problem here? Yeah, we don't want a constant. So that hopefully will give us something. And yeah, that puts me right on close to my finish time, so that'll be a good place to wrap up. All right, let's get something to drag. Oh, yeah, there's that bug where if they're over the collider, then it drags the background as well. Okay, so we get that there. It starts to move the camera. It feels like a little bit too soon, but you can get a nice quick drag, but a fair amount of control for slow. Are we? Okay. It wasn't going diagonal. It can go diagonal. And yeah, it wasn't just because it was at the edge there. So not going outside our bounds. Bring this all over the place. Okay, and there. Yep. Feels like it starts a little soon. So that's where I adjust this from 15%. Let's try 10%. And I'll just do it zoom to trigger that to happen. So yeah, that seems good enough. I can tweak that later if I want to. I wonder, should I, instead of having them all based on the lesser dimension, instead have them based on just the relevant dimension? Do we have any room to pan up or down or anything? Just a little bit to the side. Yeah, well, that's good. That seems to work quite well. So I'm going to call that finished. So I will move that to there to address that in the future. And now I'll just wrap this all up. So I'll make sure everything's saved here. Make sure my code is saved. And let's grab a version control. So I'll grab my Git GUI here. I usually prefer to use command line, but this has been good enough. Okay, good. So that's got our new things. Oh yeah, 10 was better there. Just make sure I've got that set to 10 there. I need to put a lot of these things into scriptable objects so that I can tweak them while playing without it being lost as soon as play mode ends. Okay, so we're good there. And that's our updates to the camera drag. Oh geez, that's so annoying. Need to figure out the I always forget what the magic set of things to do to stop that happening are. This is just like Windows line endings versus Linux line endings, basically. Doesn't tend to affect much, but can affect some things sometimes. So I do like to just set things up so everything will just use one type of line ending. Anyway, we've got those new serialized fields being added. This to do is not relevant anymore. Let's get rid of that. Now I could definitely clean this up somewhat. Like all these comments, I should be using the naming of these to describe the code. Don't need that logging. That's going to be a lot of logging. Or swamp any other logging I try and do. You can inline this. It feels like a weird way to do it. Yes, don't need extra stuff there. Does this automatically get rid of the thing? Yeah, good. That white space from here to here, don't need it. Looks ugly in the diff. So pause is being used in a few places. Game size is 2. This is being used only in one place, so I think we can inline that. And this one. Okay, good. We've got our distances used, thresholds used in a few places. So is that. Okay. Offset and direction. Yeah, they're fine as separate things. It's not going to slow the code down at all. I'll optimize all of that out. And that just seems to be working as well, so I'll delete the old bit there. Don't know what that was there for, but we'll get rid of that. Yeah. All right, great. So now I got rid of that to do. I guess that's okay with those extra comments. I can remove them if they seem superfluous later. Oh, hey. What have we got here? Oh, it's just spam. No, not going to buy viewers and followers. Although it would help more people find my content. Let's just let that happen organically, hey? Cool. That looks all good. So what did we do? We did that. Very advanced speed based on distance edge. That sounds like a description of what that does. And we're all good, and I'm slightly over time, so I better end the stream there. Sorry, Spambot. Unfortunately, I don't have time to deal with your BS. So, genuine viewers, on the other hand, thank you so much for watching. Next time, I guess I'll be fixing those bugs. And so that's in a couple of days, unless I find a bit of time sooner. But life keeps throwing things at me, so maybe that won't be sooner. Anyway, thank you so much for watching. Like, subscribe, etc. Do all of those things if you want. It'll certainly help me to see some numbers that are slightly bigger, and who knows what that could do.